Hey guys, Mr. Marone here. Welcome back in. You are now in lesson 4.2, so we're now focusing in on triangles. We're moving away from just the general idea of congruence. We're going to use congruence a lot through this section, but the main focus will be on triangles through that. Today we're going to look at two what are known as special triangles. Not that they're more special than any others, but that they have some special relationships within them. The first type we're going to look at in this video is going to be the isosceles triangle. And then in our next video, you're going to see the equilateral triangle, which are the easiest to use of all. So in the isosceles triangle, there are two rules that come out of this, or two relationships that happen, and they go either direction. That's why in your notes you see that there's a theorem and a converse. They work both directions. And it tells us that in an isosceles triangle, which looks like this, you have two what are called legs, and then you have a base. And this tells us that if AB and BC are the same length, in other words, if the two legs are the exact same measure, then the two base angles are going to be congruent. So in every isosceles triangle, the two legs are going to be congruent, and that tells us that those base angles, the angles that are created by the legs and the base, are also going to be congruent. And this works both ways. If you have base angles being congruent, then your two legs will be congruent. It's a great tool, and it makes life so much easier when we can get to an isosceles triangle. Looking at this example, this is a real-world example. This is showing the person designing a community park between two different streets cut by Park Plaza. They tell us that the pathways on either side of the pool were going to be in equal length. So in other words, from D to F and from D to E are going to be congruent. They've marked those with their congruence marks. As soon as you see that in a triangle, that immediately tells me that my two base angles are going to be congruent as well. They want to know what angle measure should the architect specify for those two angles. The inside of every triangle we know is 180 degrees. So if I've got 180 degrees, these two angles are going to be the same. So algebraically, each of them would have a value of x. So that 180 is going to equal the 50 plus x plus x. If you do the algebra out to solve that, you would end up getting 130 equals 2x, so x is going to be 65 degrees. So if I gave them two angles of 65 degrees each, plus that 50-degree angle, it would work perfectly. Now, if you also wanted to take the non-algebraic route and just did 180 minus 50 and got 130, and then divided that by 2, you'd also end up with 65. Both methods work perfectly. I want to give you the chance to try to solve this one on your own. Now they're asking for the length of all three sides. They need us to find x first before we can find the lengths, and they gave us that these base angles are congruent. That tells me that PR and that RQ have the same measure, that they're congruent to each other. Go ahead and set those equal to each other and solve them, and when you unpause the video, you'll have the value for x, and then we can find all three sides. Go ahead and try that now. All right, welcome back in. So as you see here, I solved out by setting them equal and then multiplying those threes. I ended up with x equals 12. So if we plug that in for each of our measures, I'm going to save you some time here. If I look at these two, x plus 20, 12 plus 20 just gives me 32. Instead of plugging into this kind of messy looking thing here, we know these two sides are exactly the same. So that one's just 32. We don't have to do the extra math there to find it out. With this one, we do have to do the math. So 6 times 12 is going to give me 72, and I'm going to subtract 12, so that's going to give me 60 for my measure there. Okay. Now, we've got one other piece of information that comes from isosceles triangles. This is a theorem about what are called segment bisectors. So we've talked about those. If we bisect a segment, we end up with a bunch of extra information here. So this tells us that if a line or a line segment bisects the vertex angle, which is the angle that's not our base angles. So in this triangle, we've got isosceles here. AB and BC are the same length. So these two angles will be the same measure down here. If this is a segment bisector, if we have a bisector there, then it's also called the perpendicular bisector. In other words, when we draw in a line from our non-base angle straight down, this creates two congruent triangles here. It's going to make AD be congruent to DC. So it's going to make those measures the same. And then we end up with two of the exact same triangle there. So it creates a lot of help for us in that case. So we've got one more example to look at. This is a prefab house which exists all over the place. And they want us to figure out, should this truck be able to get under a clearance that's 17 feet. So the house from the bottom of the roof to the bottom of the house is 10 feet. And they gave us that this whole length was 28 feet. If you notice here, they've given us the same type of setup we had up here. If I take my marks out, then we've got really the same exact problem. When we have this angle bisector here, that means that these two sides are going to be the same length. If the whole thing's 28, that means this piece is 14 there. And it gives us a perpendicular bisector, so that's going to be a right angle. So what that gives us here is a right triangle with 16 and 14, and there's my right angle. And we need to know if this height is less than 7, because that would make the whole house less than 17. So we can use Pythagorean theorem there, something you guys spent tons of time on in middle school. So hopefully you remember that you've got 16 squared equals x squared plus 14 squared. Go ahead and solve that, and when you come back in, we'll be able to verify whether or not this house fits under this bridge with 17-foot clearance. All right, welcome back in. So solving out, we find that that this piece here is 7.74 feet. So that tells me that total, if I add 10 to that, I've got 17.74 feet. So no, this will not fit under that bridge. That would hit the bridge, and if you guys have ever seen a truck hit a bridge, it's not good. You should go take a look at YouTube and watch some trucks hitting bridges. It's pretty funny, actually. That's it for isosceles triangles. They're a wonderful tool. We're going to use them throughout the entire year, so hopefully this gave a little bit of clarification on isosceles triangles. If you have any questions, please bring them into school tomorrow, and I'll see you guys then. Have a great night.